Welcome to Power Law of Logarithm without using table. In this lesson, I will be walking you through how to make use of power law to solve logarithm problems without using table. So when we talk about power law, what does it state? It states that when a logarithm is raised to a certain power, the power can be used to multiply the logarithm itself. Well, mathematically, we can represent this as we having log s raised to power n in base a equals to n times log x in base a. So what does all this mean? Well, look at this is the number we are looking for, the log, which is the x. This is the number, and this n is the power. This a is the base. So what this power law says that when we have any log in a particular base and it's being raised to a power, that means we'll use the power to multiply the log. As you can see here, we just take this n to the side to multiply the log x in base a. You can see that. So we can rewrite this as n log s in base a. You can see that. That's good. So let me walk you through examples so that you can understand better what power law is. We're looking at the first example. Simplify the expression log 8 in base 2. So we're given this expression to simplify. You need to see now that this 8 now, it looks as if it doesn't really look like we are applying power law here. But I'm going to show you some trick that you can use. So what you need to do is to break this 8 down, and we're going to make use of the short division to do that. So take your 8 and look for the smallest number that can go in 8. That smaller number apart from 1. So 2 can go in 8. So we're going to try 2. How many times will 2 go in 8? That's 4 times. So what can go in 2 again? 2 can go in 4. Oh, pardon me. What can go in 4 again? 2 can go in 4. So we have 2 in 4. That will give us 2. What can go in this 2 again? 2 can go again. So we have 1 left. Good now. So that means for our 8, we have 2 times 2 times 2. That's like 2 in 3 places. So instead of writing this 8 now, we can call that 2 in 3 places 2 raised to power 3. So we now have something like this, log 2 raised to power 3 in base 2. You get the idea? Good. So if we compare what we have now with a power law formula, that's log s raised to power n in base a. If you compare that, you can see that the base here is 2. It's like this a, and the 2 here is the x, and the 3 here is the n. You get that now? So all we need to do is to take this 3 to the side to multiply this log, and we have something like this, 3 times log 2 in base 2. You get that now? Then you also remember in our former lesson we talked about it, that if you have a log of a number in the same base, that means you have a particular number, you're looking for the log of a particular number that is in the same base. Such kind of log will give you 1. For instance, you're looking for the log of 2 in base 2. Or let me give you an instance again. You're looking for log of 5 in base 5. That will definitely give you 1. Just a recall on that. Okay, for this particular scenario now, so this one will give us 1, and so we have 3 times 1. You get that? So what is 3 times 1? 3 multiplied by 1 will give 3. So our log 2 in base 8 finally will give us answer to be 3. Good, you're doing great. So let's look at the second example, which is example 2. In this example, we are asked to simplify the expression log 81 in base 3. So given the question now, all we need to do is to break the 81, because as you see the 81, it doesn't really look like as if we can apply power law to it. But we need to break 81. So we're making use of the short division to do that. So take your 81 and then look for the smallest number that can go in 81. 2 cannot go in 81. So 3 can go in 81. So we're going to try our 3. 3 can go in 81. So we're going to start with the first digit here, which is the 8. How many times will 3 go in 8? That is 2 times. So let's write the 2 down. Then remainder what? 3 times 2, that will give 6. So 8 minus 6, that is 2. So remainder 2, let's write the remainder 2 on top. Good. Now next thing is we need to take this number, which is the 1, the second digit, we take it up to the other 2, and then we have 21 there. Then we now say 3 in 21. How many times will 3 go in 21? You can quickly go into your times table. You know that 3 times 7 will give 21. That means we'll have 7 there. So next thing you need to do, what number can go in 27? And that number is 3. 3 can also go again in 27. How many times will 3 go in 27? That's 9 times, because 3 times 9 will give 27. So we have 9 there. So what can go in 9 again? 3 can go in 9 to give 3. Yes, 3 times. So what can go in 3 again? 3 can go in 3 to give 1. Good. Now that means for our 81 we have 3 times 3 times 3 times 3. That is 3 in 4 places. So we can call that 3 raised to power 4. You get that now? So instead of writing our 81 now, we're going to write that 3 raised to power 4. So we have log 3 raised to power 4 in base 3. You get the idea? Good, you're doing great now. Then according to the power law now, this power that we have here, what's the power? The power here is 4. We're going to use that 4 to multiply the log. That means the 4 will come to the side. So we have 4 times log in base 3, 3. You get that? Good. Now then log raised to its own base. As you can see here, we're looking for log 3 in base 3. That means that will give us 1. So we have that to be 4 times 1. You getting it? And what is 4 times 1? That will give us 4. So we have our log 81 in base 3 to be 4. Good. Wonderful. Wonderful. You're doing wonderfully. Let's look at the next example, which is example 3. Simplify the following. Log square root of 32 in base 2. Don't let this question scare you because of the square root. Wow. Sit back. I will show you how to do it. It's simple. Be rest assured. So the first thing we need to do now is this square root. What does it mean? Whenever you see square root, what does it really mean? Okay, square root really means raised to power half. If you're being given like you have square root of 32 now, what it simply means is 32 raised to power half. You get that now? What if you're given like square root of 5? What does it mean? It simply means 5 raised to power half. What if in another scenario whereby you're not given a square root, maybe you're given cube root of 8? What does it mean? It simply means you have 8 raised to power 1 all over 3. I hope you understand this. I just did all this for you to get a full understanding of what I'm explaining. Good. So now that means this is our square root now. We can say we have log 32 raised to power half in base 2. You get that now? We just bracket this because we want to break this 32 up. That's the reason why we bracket it. So we're going to break our 32 up now using our short division. So let's use short division. What number can go in 32? 2 can go in 32. So let's see how many times will 2 go in 32. We're going to start with the first digit here. How many 2 will go in 3? That is 1. So remember what? Remember 1, because you say 2 times 1, that will give 2. Then 3 minus that 2, that will give our remainder 1. You get that now? Then take this number, which is the 2, the second digit, take it up now, and then we have 12 there. So ask yourself now, 2 in 12. How many times will 2 go in 12? If you go to your 2 times table, you know that that will definitely give you 6. 2 times 6 will give 12. So we have 6 there. The next thing you check out is what number can go in 16 again, and that is 2. 2 can go in 16 again. How many times? That is 8 times, because 2 times 8 will give 16. Good, you're doing wonderfully. Then let's look at which number can go in 8 again. 2 can go in 8 again. Good. How many times? That's 4 times. So what can go in 4 again? 2 can definitely go in 4 again. And so how many times? That will give 2 times. What can go in this 2 again? And that is 2. And that will give 1 time. You get that? You're doing wonderfully. That means for our 32 now, we have 2 in 5 places. So we can call that 2 raised to power 5. You get the idea? 2 raised to power 5. So now what we need to do now, this 32 now, we're going to write 2 raised to power 5 there. And so we have log 2 raised to power 5 in bracket, then raised to power half. You get all those jigs, then in base 2. Good, you're doing greatly now. Then the next thing we need to take note of is this. We have this 2 is raised to power 5, and then it now raised to another half again. In this kind of scenario, we apply what is called the power law of indices. And what the power law says is this: you're going to take the powers and you multiply them. And what are the powers that we have here? We have 5 and we have half. So you are going to take 5 times half. You get that now? And we have something like this: log in base 2, and we have log 2 raised to power 5 times half in base 2. You get the logic now? Good. So let's try to do the 5 times half. 5 times half. Good. Now you know that 5 all over 1 is the same thing as 5. So the reason why we're doing this, because we have this fraction 1 over 2 here, so we need to multiply. So 5 is at the numerator, 1 is at the numerator, so we can multiply 5 times 1, that will give 5. Then let's multiply this 1 times 2, that will give 2. So we are all over 2. So we have 5 all over 2 there. Okay, now so our next thing now, 5 times half give us 5 over 2. So we have log 2 raised to power 5 over 2 in base 2. Good. Now if you look at now this where we are now, I want you to look at it very well. It actually resembles that particular position where we make use of the power law. All we need to do, you can see the power right here now. We've broken down the number, and we now have 2 raised to power 5 all over 2. All we need to do now is to take this 5 over 2 to the side. That is what the power law says, because 5 over 2 here is a power. So we can take it to the side to multiply the log. And so we have 5 all over 2 times log 2 in base 2. You get the idea now? Good. And then what is log 2 in base 2? You remember log 2 in base 2 will give 1, because if you have log, you're looking for the log of a particular number that is to the same base. Definitely that will give you 1. So we have 5 all over 2 times 1. And 5 all over 2 times 1 will still give the same thing as 5 all over 2. Good. You know 5 all over 2 is an improper fraction. You can decide to convert that to a mixed fraction. And to convert that to a mixed fraction, you just ask yourself, how many 2 will go in 5? That will give 2. Remember what? Remember 1. That means because 2 go in 5 2 times, you say 2 whole number, and for the remainder you say 1 all over 2, and so we have our final answer to be 2 whole number 1 all over 2.